Hello Knights and welcome to Intro to Inequalities. We're going to start our lesson by taking a look at this chart that is over here to the left. There are symbols in there, their meaning, and an example. We're going to look through each of the rows. So that first row, we have the symbol. It tells us the meaning of it is less than, and then it gives us an example, a mathematical sentence right here, which is read as 3 is less than 5. 3 is less than 5. Go ahead and read the rest of those rows to yourself. Pause this video and write down 2 things that you notice right there. All right, Knights, at this time, you have written 2 things that you've noticed about this chart and reading it. You probably noticed a lot of things, but I want to draw your attention to the fact that you have likely seen these symbols before when you have been ordering or comparing numbers in various math classes throughout your years. These symbols that are in this column here are called inequality symbols, and you may have learned just these 2. You might have also learned to turn this one into a little alligator so that it's always eating the bigger thing. You might have learned to make it look like a Pac-Man so you know which bigger thing it's eating. Either way, you've likely seen these before. The ones you may not be as familiar with are the ones with the lines underneath. The ones with the lines underneath have a very important distinction. They also mean or equal to. So in this case, less than or equal to, or greater than or equal to. And the equal sign with the slash through it, which means is not equal to. This brings us to key point number 1, which reads, an inequality is any mathematical sentence that has an inequality symbol. It is used to compare numbers. So I already let you know that this column right here, all these symbols are called inequality symbols. And anytime you see that, such as in our example here, of 3 is less than 5, that whole thing together is called an inequality. Inequality. The prefix here of in actually means not. So this word means not equal, just like 3 and 5 are not equal. Using our newfound knowledge of these symbols, we are going to take a look at letters A, B, C, D, and E, and we are going to write the corresponding inequality for what they mean. So let's take a look at the first one. We have 7 is less than or equal to 23. So I have my number 7, I have my number 23. And I need a symbol that's going to represent less than or equal to. So I'm going to take a look at my chart. The row that says less than or equal to is right here. That symbol looks like this. I'm going to write less than, make sure you have that line underneath, or equal to. Less than or equal to. Go ahead and pause the video at this time and do letters B, C, D, and E on your own, and unpause when you're ready to check your answers. Okay, welcome back. Let's take a look at letter B. We have here 56 is greater than 28. I looked at my chart and I know that my greater than symbol looks like this. My little alligator is eating 56 because it is bigger. 56 is greater than 28. Letter C, 98 is less than 100. I put in my symbol for less than. This reads 98 is less than 100. Letter D, 2 is not equal to 5. We now have a new symbol for that. It's an equal sign with a slash through it. 2 is not equal to 5. My last one has a variable in it. X is greater than or equal to 12. Little preview where we're going next. X is greater than or equal to 12. Greater than is this symbol. The line underneath tells me it could also be equal to it. Let's take a look at our next task. Write the symbol that makes the statement true. So here it's already given us the numbers, and it just wants us to write the statement that makes it true. You may notice my boxes here are a little wonky, but yours are not. So go ahead and just ignore them here. Do them on your own notes. We have 2 and 12. There are a few different symbols we could write. I know that 2 is less than 12, so I could put my less than symbol. I also know that 2 is not equal to 12, so I could have put my not equal to symbol. I also know that it is less than or equal to 12, so I could have put that symbol as well. So for this one, there are 3 options. Go ahead and try B, C, and D on your own, and then unpause when you're ready to check. Welcome back. For letter B, we also had some options. 1 is greater than 0. Also, 1 is not equal to 0. So I could have done my equal sign with a cross through it. It's also greater than or equal to 0. So I could have put that symbol as well. 3 and 5/10 and 3 1/2. There's only one symbol that we know that we could put in between those, and that is our equal to symbol. Those are equal. And lastly, we have 18 and 20. I'm going to draw myself a little box because mine is not in the right place. 18 is less than 20. You could have also put less than or equal to or not equal to. All of those options would have been just fine. Moving on, for any 2 numbers, A and B, only one of the 3 statements is true. A is less than B, A is greater than B, or A is equal to B. So we would just want to think of any 2 numbers at all. So for this example, I'm going to use A is equal to 1, and B is equal to 2. In this situation, only one of these 3 statements can be true. And the statement that's true is that A is less than B. I can change my numbers. So A could be equal to 15, and B could be equal to 2. And in this case, this is the statement that would be true. A different scenario, A is now equal to 3, and B is also equal to 3. The statement that's true is that A is equal to B. So this is just telling us that in any situation, for any 2 numbers in the entire universe, only one of these 3 things can be true. This one can be true, or this one can be true, or this one can be true, but not all 3, not even 2 of them, just one at a time. Only one. This is going to be important as we move into our number lines, and you will find out why in a moment. So let's go ahead and take a look at our key point number 2. We have made it. Key point number 2, a number line is a graphic representation of all numbers. So your fill in the blank here should be number line is a graphic representation of all numbers. Every single number on the universe you can put on a number line. That's exciting. We're going to go ahead and plot and label the numbers on the line below. I'm going to do A for you, and then you're going to pause this video and do the rest of them. So let's take a look at the letter A. Point A is 3, so I'm going to make a little dot right at 3, and I'm going to label that point A. I did that one for you. I want you to pause the video, do B, C, D, E, and F, and unpause when you're ready to check your answers. Welcome back. At this point, you should have labeled point B at 2 and 3/10. That would probably be right about here. It's okay if you estimate. Point C at 4 1/2. It's exactly halfway between 4 and 5. Point C. Point D is at 1. That's an easy one. D. E should be at 25 hundredths, which we know 25 cents of a dollar, that's 1/4, that's 1/4. 1/4 would be about right here, point E. 3 and 6/10, that's going to be a little bit more than 3.5, 3 and 5/10, so I can put an F right there. All of my points are now labeled. We can take a look at our inequalities below. We want to write 3 true inequalities about our points. So the first points that it's asking us to take a look at are points A and E. So locate those on your number line, points A and E. And we want to write 3 different inequalities that are true about them. So the first thing I know that's true, I see A is right here, I see E is over here, is that A is greater than E. A is greater than E. I also know that it's greater than or equal to E. I could also have put that inequality. And because they are not at the same place on the number line, they are also not equal to each other. So go ahead and pause the video now, and I want you to do the same thing we just did, but with points E and D. So point E right here, point D right here. Go ahead and write 3 true inequalities about those points. All right, let's check those together. I know that D is greater than point E. It can also be greater than or equal to, or I could have put not equal because they're not at the same place on the number line. We just identified something that's important about our number line, is that the numbers to the left of a point are, write your prediction, are they greater than or less than that point? So if I take a point, for example, point C, right here, are the numbers to the left of it, are those points greater than or less than C? Greater than or less than that point? You're right, it's less than. So right here you want to write less than. Less than. Numbers to the left of a point are less than that point. Now it's asking us numbers to the right of the point are what? If we took our same point C, everything that shows up on the number line in this direction, should it be greater than or less than point C? You're right, it's greater than. Greater than. Every single point that is this way from point C is going to be greater than C. This brings us to key point number 3. Number lines are used to represent inequalities. The blank, which is the graph of an inequality, that's just when an inequality is written on a number line. The graph of an inequality represents all possible points that would make the inequality true. The set of possible points is called the solution set. So I'm going to write the solution set. The set of solutions. We're going to look more into that right here. Go ahead and take a look at these 2, one here, graphs of inequalities, and write down 2 things that you notice right there. Go ahead and pause the video and write down 2 things you notice about those 2 graphs. Wonderful job. I'm going to just talk about some things that I notice. I notice that for my x is greater than 3 graph, which is this one, that the point right here at 3 is an open circle. And in my graph that represents x is greater than or equal to 3, that my 3 point here is a solid point. So I have a solid point with an arrow attached to it here. I have an open point with an arrow attached to it here. That's something that I noticed. Maybe you noticed the same thing or something different. There's a question down here below. How is the solution set of the inequality x is greater than 3 different than the solution set of x is greater than or equal to 3? So if we're thinking about x is greater than 3, this right here, the solution set is going to ask me, what are the possible values of x? What could x possibly be? Could it possibly be 1, No, because 1 is not greater than 3. Could it be 2? No, because 2 is not greater than 3. So our solution set is going to have everything that is greater than 3. For this inequality right here, greater than or equal to 3, my solution set would look like, could x be 4? Well, yes, because that's greater than or equal to 3. Could it be 3? Yes, because 3 is greater than or equal to 3. So for this solution set, it can be 3. So x can be 3. That just disappeared. For this one, x has to be greater than 3. So x cannot be 3. X cannot be 3. And I think that that is the difference that we need to pinpoint between these two inequalities, because they look very similar. But there is one important difference, and it's that for x is greater than 3, 3 is not included in our solution set. And for x is greater than or equal to 3, 3 can be included in our solution set. All right, moving on to key point number 4. When using a number line to graph an inequality, inequalities using greater than or less than, that says less than or greater than, we'll use open circles on the number line. Inequalities using less than or equal to or greater than or equal to, we'll use closed circles on the number line. So if we look back up here, we should notice that x is greater than 3. We used an open circle for our 3 because 3 is not included in that solution set. Whereas here,
here at top, if you are in the building, please come to the front office. Here at top, if you are in the building, come to the front office.
If that's you, go to the front office. Okay, for our solution set of x is greater than or equal to 3, you will notice that there is a closed circle here because 3 could be a possible solution for x. So let's look down at these examples here. The first thing it wants us to do is write the inequality represented by each graph. So for letter A, I know that x needs to have some relationship to 15 because that's where that dot is right there. I know that x is less than 15 because that dark arrow is going in this direction, and everything in that direction is less than 15. So x needs to be less than 15. My dot there is filled in. It's a closed circle. So I know that I need to choose one of these two inequalities here. So it's less than or equal to. Less than or equal to. Let's look at number 2. I know that x needs to have some sort of relationship to around 16 and a half. 16 and 5/10 is about where I'm going to estimate that dot to be. My solution set includes everything in this direction. Everything in that direction is greater than 16 and a half, so I'm going to put a greater than symbol. And it has an open dot, so that means that 16 and a half is not included for possible options, so I'm going to leave my symbol just like that. In this next piece, it's asking us to graph the solution ourselves. So in our first situation, it says x is less than or equal to. If you cannot remember what those symbols mean, go all the way back to the beginning of your notes, take a look at this column, and figure out what the symbol means. So all the way down at the bottom, all the way down here, we have x is less than or equal to 14. First thing I'm going to do, put my pen on 14. You see a little dot there? That's where my stylus is. Less than or equal to 14. Well, everything less than 14 is this way. So that's the direction I'm going to draw my arrow in. Now I need to ask myself, is it included? Is 14 included in the possible values for x? Well, my inequality symbol here is less than or equal to. So yes, 14 is included. I'm going to do a closed circle. Let's look at the next one. X is less than 55. So the first thing I want you to do is identify where is 55. X is going to be less than 55. So we need to draw our arrow starting at 55 in the direction of things less than 55. Everything less than 55 is this way. So that's where my arrow is going to go. Now I need to ask myself, is 55 going to be included in my solution set? Is it? Yes or no? Nope, it's not included because x needs to be less. So right where I see 55, I need an open circle. An open circle. Because 55 is not included. Congratulations, you have made it to the bottom of the notes. I will see you on Monday. Bye, Algebros.